Hello everyone, welcome to Learn Overflow. In this video, we'll be discussing about the merge sort algorithm. So we'll discuss how this algorithm works. We'll try to understand the exact working of this algorithm. We'll then try to implement the algorithm with the Python code, or we'll see the Python implementation of the code. And at the end of this video, or towards the end of the video, we'll just look into the exact time complexity of merge sort algorithm. We'll just try to figure out how this merge sort algorithm uh, takes time and what are the problems or what are the benefits of this merge sort algorithm. So to start with, Marshall algorithm is one of the efficient algorithm and we use it for a general purpose, and this is a comparison based sorting algorithm. So in master algorithm, we work on a divide and conquer strategy. So we first divide our array and then we conquer those parts or sort those parts. And the complexity of mark sort is quite good. That is a sorting algorithm. For a sorting algorithm, we get here n log n complexity, and that's remain constant for best case, average case, and worst case. So that's the thing here. So for mark sort, the complexity of time complexity rather remains constant. But the problem mark sort gets is its space complexity. For mark sort, space complexity goes to n. Like it takes a huge number of space. And it creates new memory location for every step it moves forward. We'll see how it happens. We'll see how it works. So let's start with the understanding of this algorithm. So here we have an array with us. So this array, look here, this array is the length of this array is 7. So the length goes from 0 till 7, 0 till 6. Ignore this 1 as of now. I'll tell you how what this 1 is doing here. This is not the index number. All right. So the length of this array is 7, and this array we need to sort this using merge sort algorithm. So what happens in merge sort? We first somehow break the array, or we break the array in two halves. Okay, so how long we break the array? Till we get single elements in the array. So we'll see. So first of all, we'll break the array in two halves. The first half would be this part and the second half would be this part. So this breaking goes on like there we have 7, like this goes on like 7 plus 0 by 2 becomes our 3.5, and we take the seal of the value and that becomes 4. So then it becomes 4 in first part and then 3 in other part. So that's the basic division. We just divide it in, we try to divide into equal halves, but in case we have a fractional value, we give one more in a side and one less in a side. So that's how we just divide it. So that doesn't matter. You can divide it in any manner. Like you can divide, try to divide in a, equal halves. That's the basic reason. Okay. Next thing, after division, what happens to this algorithm? So after division, the algorithm uh, breaks into two parts. So one is this part and the other is this part. You can see that I didn't change anything. Nothing happened till now. So just a new memory location got created with this four array elements and this three array elements. So these three are basically this three array elements, and this four are just this four array elements exactly placed together. All right. Now that's the first step to bring. So this is step one for us. So in step one, we just break it in two parts. One, there are four elements, and one, there is three elements. Moving to step two, if we just focus on step two here. So in step two, we again did our same task. We again broke our array in two parts. So one is this part and another is this part. So this part is basically 23 and 24 written exactly in order. So nothing of sorting happened yet, and they're 5 and 3 written exactly on order. So till now we haven't sorted anything. We just divided our array and created new memory location, right? A new memory location got created, and that's how we just sorted. We just divided our array till now. So I told you in the beginning, the master is a divide and conquer. So first we need to divide the array to the fullest. Okay, we'll divide it as far as we can. Next step, we'll look at this part. So what it is again we are doing the same thing. It's again we're doing the same thing. We basically divided it in single array elements. Look, now we are end to single array elements. Now we are just left with one array elements each. So when we reached a condition where we got one array elements, then for us what would happen? When it is single array elements, then comes conquer. Like we just broke it in the maximum possible value, and then comes the conquer. So after conquer, look what happens here. So here we had 23 and 14 in step 3. In step 3 we had 23 and 14. So in step 4 we got 23, and in step 5 we got 14. So once we figured out that these are the single elements, they are not double elements, we just found these are the single elements. So once we find out these are the single elements, then what to do? Then we need to sort it. So now we are conquering this. So now what happened? 14 came at the beginning, and 23 came at the end. In the second place, right? So 23 was in the first place, and after the sorting here, 23 came at the second place. So this became our step number 6. So this became our step 6. So look here, we went for 3, this was 4, this is 5, which is broke, and then at step 6 we got our first conquer. Okay, moving on to step 7. Look here how it worked here. So in step 7, again we did the same thing. We broke it into this array elements into much larger, much singular module. So what we found out, we found 5 and 3 were broken into two different elements, and that those were step 8 and step 9 of dividing those elements. After breaking them to the ultimate of single array element, we again try to conquer those parts. How do we conquer those parts? We just sort those parts, and that's the step we used for conquering. After conquering, it's become 3 and 5. So they got sorted. This at step 10, you can notice that this array elements got sorted, right? This array elements got sorted here. So we sorted this in its exact order. After step 10, we need to see that we divided this part, right? Here after step 10 down here, so what happened? We got two different sorted arrays that we broke out from step number 2, right? From step 2 we broke out into two different arrays, steps 3 and step 7, and after step 10 we figured out that we got both of those sorted. Now it's time to combine those two. For combining those two, we move forward to step 11. What we do, we take this part, left hand part, and we take the right hand part, and we combine it. Like we take the lowest value first. We are sorting this in an ascending order, so we just look at, we're doing the same here. We're taking the lowest value first, then the second higher value, then the third higher value, then the fourth highest value, right? This is the step we just broke it out. We just sorted it. If you just look carefully at step 11, what we are left at step 11, we are basically left with an array that we started at step 2, and at step 11 we just solved those array, or we just sorted this array, right? Now it's time to move to the other half of our it's time to move to the other half of our array, that is those three elements that were left, right? So these three elements that were left, that we used marked as a different part, so it's time to break those part. So here we broke it into this way. So here we have three elements, so we cannot break it in two, so we break it in 2 and 1, right? We broke it in this manner, like 2 and 1. So for the first step contained the two elements, that's the step 13. We got two elements here broken out, and in step 17 we got one element, that was the single element. So we got one element, but look, we cannot conquer this part since we have only one element. We need two elements to just sort that, right? So moving on, what you do at step 14, at step 14 we basically dividing this step 13 in two equal parts, like two single modules, or the lowest minimum value that we can break into. Moving on, after step 17 we move forward to step 18, and here after step 14 and 15 we find step 16. So what is step 16? Look, at step 16 we actually conquered step 13. We conquered the parts that were there in step 13, right? We broke out this part at step 13, and I finally sorted this array, the small array, at step 16, right? At this step, we sorted this array. Moving on, we had this step 16 and step 17. What is this 18? Why just wrote it one more time, since it's actually the same array coming out from here. So we had step 17 and step 18, 16 and 18 here. So in 16 and 18, you can see the sorting is to be done. So how this happens here? This takes again the same step, that is the left element, like the 19 comes here from the first element to the first position, then 20 being the next highest element comes in the middle position, and then 32 being the highest element among these three elements comes in the last position, right? So that's how what comes as an output of step 19. Look carefully, step 19 was just the result that we broke out in step 12, right? So step 12 was the broke out part, and we saw this in step 19. So the numbers that I wrote below are the step numbers. So after step 19 is over, is the most crucial part. We will get our sorted array. So how we'll get our sorted array? So for our sorted array, again we will get elements from the left array, and we'll get the elements from our right array, and we'll sort it. So how? We'll just take one element from the left, being the lowest. If find the lowest was 3, next we got 5, next we got 14, next we got 19 to be the next one, right? We just placed it here. Then 20 was the next highest element. Then 23 was from the left array. 23 came up. Then 32 was the last element. So 32 came. So at the last step, this is the last step we have here, and this step gives us a sorted array. This array we were asked to sort was result, and we found that as a result in step 20, right? In step 20 we actually sorted this array. Look here, so this was the array that we had been given to sort, and this array got sorted in step 20. So remember, in this case I just showed here a different array, different array positions. It's because this is creating a new memory location every time. Like till here, if you just notice carefully, till this step, all right, till this step, if you just move look upwards, so every time you see a new array element, it's creating it at a new memory location. Okay, so every time you see a new array element, it's created as a new memory location. So each time we break an array, it's basically we are doing it on a recursive manner, and every time we are calling a new function call with a different array list, it's basically creating a different array memory location. We're allocating a different memory location for that. Yes, merge sort is much faster than a few others like insertion sort, selection sort, or bubble sort. If you haven't seen those videos, I will post the links in the I button above. Just have a look at the I button. You can understand how those functions work too. So in this functions, in merge sort, how it happens, merge sort is the best sorting algorithm that comes up with an best case or worst case or average case time complexity to be n log n. But this the only problem it arises is it creates new memory location. All right, so every time it just goes on creating new memory location. So that's the problem. If you are running low on memory, so then merge sort is not a biggie, easier method for you. But nowadays memory issue is a lot less issue, since we got every devices we get actually high on memory, right? So we find martial art to be a much faster uh, process to sort an array, right? So, like for a huge array length, we just array or list, we just get it sorted in a much shorter time, right? Now, after we just found out how this merge sort algorithm works, why not we just try to figure out how we can implement merge sort in our Python algorithm. All right. So here is the Python code for you. Let me just rub this part a bit. So okay, I hope this can make you understand. Okay. So let's look into this Python code a bit. I'll just zoom it a bit. All right. So in the left side, you can see the exact algorithm working, and the right side, you can see a Python implementation that I bring for you. Now, let's understand how this implementation is working. So as usual, we are calling a merge sort in the initial function in the starting, and we are passing a whole array AR. So at the beginning, when you're passing AR, so that means we are passing this array, right? So we are passing this whole array. Now, inside Marshall, we just see a important check. The start of this function starts with a check. The check is that the length of array we received here should be greater than 1. Why greater than 1? Once this is greater than 1, so every time we encounter this step means we are up to this place. See, we are above this place means we are getting a true value in this check condition, right? Once we reach this step, once our we reach this step, we would definitely get a false in this value. Since we need to reach a single array element, there's no need to break it into parts, right? There's no need to break it. So we need to sort it. That's the time for sorting. So from this statement, from this step, like this stage that you can see where single elements are there, this if statement would go false, right? So that's the condition to break it into singular elements. All right, moving on to the next line. What it says, we are finding out the mid. Exactly what we did here. We just found out the mid. We just divided the length of array by 2, or we just found the floor value or still value of the uh, array. Okay. Moving on, we break this into two different arrays. So one is our left array, another is our right array. So what this left array and right array is, left array is basically from 0 till mid, and right array is basically from mid till the end. Okay, so that's what we did, from 0th position till mid, and right array is from mid till the end position, right? From mid till the end position is our right array. Next, we do two things. These are the important things. We call merge sort two times. So merge sort is calling itself. That's what we do in recursion call. So merge sort is calling itself two times. First, it's passing the left array. Next, it's passing the right array. Look, when we're discussing, we discussed first we after step one, after breaking of step one, like left, right, and right array, we first called merge sort with the left array. So that's why we took step two to be this one. So this was our left array and this was our right array, right? So the left array and right array was there. So we called merge sort function with our left array. So when merge sort function again gets called with the left array, then this was the currently this uh, is considered as our ARR or the array. And then we can check for the length to be greater or not. So once length is greater, we then find the mid. So we then find the mid and divide it in left array and right array, right? This was the division we did in these two statements. And then we again called left merge sort function with the left. So we again went to step 3, that was the left of the function. So after left, what happened? After left, look, after this step, it got a left array and it got a right array, right? So it again called with the left array. So once it calls with the left arrays, look, 23, and that's the minimum value, like that's a singular value. So once 23 gets called, so this function or this condition becomes false, and once this condition becomes false, there's nothing to do within the function once this conditions become false. So this returns to the previous calls, or this returns to the previous call, and then we call the right array with 40. And again, it returns to the previous call. Now, move forward how it goes. So we just assign 4 variables here with initial value 0. So we said while I, that is less than, that is 0 currently, is less than length of L. So what is the length of L here? So left array is 1, right? So length of L is 1, and we found the 0 is less than 1 is true, and we say J is less than length of R. Again, J is less than length of R, so 0 is less than R. So what we do, we find if left array of I is less than right array of J, we are finding this 23 is less than 14 or not. So we find the 23 is less than 14. That's a false case. So when we're doing 23 and 14, we just come over to the else statement. And what we do here, we just assign to be the error. And now we are here. We are assigning error to be R of J. So 14 gets assigning to be the first value. So K was our 0th value. Look here. K is our 0th value. So 14 gets assigned to error of K. So error of 0 is R of J. R of J is 1. So R of 0 was 14 and error of 0 was K, right? So, error of 0 was nothing, so we just assigned error of 0 to be 14. All right. After that, we incremented our J. After that, we incremented our J here. So after incrementing our J, so it becomes 1, and that's not a possible case. All right. Moving on, what we find, we incremented K as well. So when we incremented K as well, what happened to that? So whenever the next value tries to get entered, it gets entered in the next position, not in the first position. Okay. Now we cannot move into this function again. Why? Because J is not less than length of R. Length of R was 1. J is now, after this statement, J became 1. So we move out of the while statement and we return here. So what it says is, while I less than length of L. Yes, this statement was true, but this statement was false, right? This was not true, but this statement was false. So this statement still remains true. So what do you do? Whatever the remaining array elements was there, we just added it to our array. So array of K is basically array of 1, and we are assigning L of 0. So I was 0 here. So L of 0, we are assigning error of 1. So what that become? 23 gets assigned here. Then we incremented I, saying that I became 1 and just making this condition to be false. And we incremented K to be 1, saying that it's somewhere after here. Okay, out of the array maybe. But we said we are out of them. We are just moving out. All right. In the same manner, this will go again and again and again, and this will work. So what is this? Either we will find that left array value is less than right array value. If that is so, then we'll assign the left array value to our new array or the array of K. Else, and then increment the ith value. Else, if we find the right array value is smaller, then we assign right array value to the array of K, like the array we are sorting in, and we increment J. And after this, within this while, after this if else statement, we just increment K, thinking that we are moving to the next element. So this way the whole while loop goes on, and after this while loop, if there remains any value, if one of the statement becomes false and we find there is a value that needs to be assigned in either of the array, so this is done here. Either value in the left array gets assigned here, or value in the right array gets assigned in this manner. So this is basically the same thing. Either we are assigning to the left array or we're assigning to the right array. All right. So this is what and how our mark short algorithm works. So this is how a mark short algorithm works. Now let's try to understand the time complexity of mark sort. So in mark sort, you can see we are just there isn't any loop as such. So how many loops are there? Look. So this one loop is here. How many loops are basically there in merge sort? So in merge sort, you can see a loop is there. So this loop runs till how long? This loop runs till just maybe till the length of either of the array. So this array length of r or length of l, this loop runs. So what is this? This is basically total length of array that we had in error. So this left and right, either left or right, is basically error by 2. So that was we did here. So this is basically this statement runs till n by 2, right? After that, what we remain? What we left with? So this runs till n by 2. All right. And so this is a loop that runs here, and either of this loop or this loop runs here. Okay, so if you just look carefully at the function here, so it's basically time complexity is basically 2 times we are doing n by 2, and there's a constant of n. So what it is, 2 times n by 2, that's basically for left array and for right array. So that's 2 times n by 2, and a constant of n, that's basically either of this while loop or the next while loop. Uh, Either we are taking the first while loop or the second while loop. That was basically constant of n value, right? And 2 times n by 2. For one n by 2 value is for this part, another n by 2 is value for this part, because we just run it till the total value, right? We break it if one of the value gets reached. So we can say it's running till n by 2 value. So in case you just try to solve this, if you just try to solve this with maybe Master's theorem, so it this falls under the case 2 of Master's theorem, and you will find out that this is this after solving this will come out as n log n. So the complexity we find here is n log n, and this is common for all the 3 cases. If you're finding out for the best case or the average case or the worst case, so it's n log n. So that's all for today's video, guys. Thank you all for watching this video. Hope I can make you understand how mark sort algorithm works, and this is how mark sort algorithm works. So if you haven't watched new to this channel, make sure if you are new to this channel, make sure you subscribe to my channel and press the bell icon as well, so that you don't miss any of the videos from my channel. Also, I make similar programming related content. Make sure you watch those too, and I hope I can make you understand a lot of concepts. Comment down if you want any specific video on any specific topics as well. I will make that. I will try to make that as well. Thank you guys for watching this video. Hope to see you soon in my next.